BSP tree has two parameters, depth and size. Both can be either increased or decreased, and each of these actions basically will have an impact over either memory render time. So let's go over the most important ones and actually explain what is the actual impact over the actual BSP tree structure. Let's say, for example, you do increase the depth. That is obviously will improve rendering time because it allows the BSP tree to split voxels and have less triangle per voxel. So it will obviously improve rendering time and during the actual triangle and ray testing. This actually is going to increase also memory because obviously more voxel will be created during BSP tree creation, and that means that the actual rendering time is going to improve as long as the actual scene and BSP tree structure still fits in the actual RAM, machine RAM. So if the actual structure does exceed the actual real RAM on the machine and start to use virtual RAM or swap space, then obviously you start to degrade in terms of rendering. Increasing the depth will also increase the number of leaf nodes because allowing more depth means that more subdivision is basically allowed, and that will create more leaf nodes. Every time a leaf node gets subdivided, then obviously the number of triangle contained in a leaf node gets divided by 2. Increasing the depth will lower the average leaf size towards the BSP tree size, because by allowing the depth, it will basically, if let's say for example you do say I want to limit the depth to, let's say 1, I have 1,000 triangles and I say you're only allowed to go to depth 1, it means that it will only create 2 voxels of 500. Even though you set the size to 10, the depth has a higher priority compared to size. So if you say I give you infinite number of depth, then obviously what it's going to do is going to subdivide, and then stop once the voxel or the leaf node contains the BSP tree size. When the average leaf size and the BSP tree size basically are equals, it means that you pretty much went to the maximum. You are really optimal. This also might have an impact by lowering the max leaf size node depending on the scene. So let's say for example it is possible that if you limit the depth a little bit too much, let's say 20, it is possible that the max leaf size will, let's say contains way too many triangles, and by limiting the depth you're not allowing the BSP tree to split this large leaf size nodes, for example. So if for example the average leaf size and the BSP tree size are matching, chances are the max leaf size will also be the same value as the BSP tree size. So it will basically make the max leaf size also go towards the BSP tree size when you increase the depth. Also, you can increase the size. Increasing the size will basically mean that you allow a leaf node to contain more triangles, and because there's more triangles in a voxel, then it will less subdivide the scene. This will have an impact on rendering time by being slower slightly depending on the values you put, because more triangle needs to be tested in each voxel or leaf nodes, and that will actually create less leaf nodes in the scene, and that will actually slower the rendering by a certain factor. So when increasing the size, decreasing the size, for example, the impact is quite minimal compared to depth. If let's say for example you were to adjust depth or size, depth has a bigger impact on the actual overall memory usage and render time compared to size. But nevertheless, it will still have an impact over rendering time. If you increase the size, it will actually get the rendering time slower. It will lower the memory usage because since you allow more triangles to be stored in a leaf node, it means that less leaf nodes or voxel will get created and less memory is going to be allocated to store these information. It will lower the max BSP tree depth depending on the scene, and it will also lower the average BSP tree depth because more triangle can be stored in a voxel. Obviously, it will go less further, deeper in the actual tree subdivision. So let's say, for example, you say I have 1,000 triangle in the scene, and my size is, let's say, 500, and my depth is infinite, for example. Then chances are it will only split the scene in two, because it will create two voxels of 500 and stop there. So even though you have a really high value for depth and also a very high value for size, you are actually preventing the BSP tree for having an optimal setting. So increasing the size to very big values like let's say 50 or 100 or even 1000, for example, is not practical. You're not actually you'll get a very poor render time. If you decrease the size, it means that the actual BSP tree is a little bit more restrictive. So it means, well, in the voxel, I'm only allowed to have much less triangles. It means that it really pushed the BSP tree engine to go deeper in the subdivision of the scene. So because it really pushes to go deeper in the scene subdivision, then obviously it will improve rendering time, because obviously it will have less triangle to test inside the voxel, and will also increase memory usage because you are a little bit more restrictive on number of triangles. So obviously the depth will subdivide even deeper in the actual subdivision, and every time you add a level 1 of depth inside the tree, it means it's actually requiring more memory. So this is something to remember, is that every time you increase the depth by 1, it means that, let's say for example you have 4,000 leaf nodes, and each of these leaf nodes contains, let's say 50 triangles. And if you increase the depth by 1 and lower the size, let's say to 25, so you're allowing a division of each of those 400 voxel, it means it will create basically 800 voxel. It will double the number of voxel just by increasing the depth by 1. So you have to be careful that increasing depth or lowering depth should not be done by a step of 10, but more or less by a step of 1 or 2, for example.